Welcome back to another sunny day in Thailand. Today we have my GEVCU breadboard, which simulates an actual running electric motorbike. We haven't seen this in a while because I got pissed off when I blew up the chips in the GEVCU, and I just put it to the side. I worked on the software a lot. I played with the physical aspects of the motorbike a lot. But now it's time to come back and revisit this and get this thing going. What happened when I blew up the GEVCU in my initial testing was this little diode pack right here went up in smoke, and that was an obvious problem. And then also I followed the circuit upstream, and the diode pack leads to this analog to digital converter chip. It looked fine to me at the time, but I thought, no, so I bought an extra one of these, and I bought a pack of 10 of those. I had this one replaced at the local cell phone repair guys, and then I kind of shelved the project. And then now that I'm back, I took my microscope to this chip and realized that there was a blackened color all around the input pin on this guy. So I had that chip swapped out, and let's see what happens. Now let's take a look at the rest of the circuit. Right now I've got 2 meters in place. This one's measuring current through the 60 volt loop, and this one is measuring voltage of the 60 volt loop. So when I do the test, these will come to life. And then we're going to take a look at the software inside the GEVCU's development environment for Arduino, because there's a couple of important settings that you have to set in the firmware, and that is the 2 wires that control how the system powers up. The first control wire out of the GEVCU comes in right here and makes this small relay engage. This is called the Precharge relay. When the Precharge relay closes, 60 volts flows through this resistor and through the loop. What this resistor does is it slows down the flow of current, because with the motor controller in the circuit, it doesn't want to have power slammed right into it, because there's some delicate capacitors on the input of that device. So by putting this 1000 ohm resistor in place, we're cutting down the current flow by 1000. So instead of full-blown power, we're going to put about 60 millivolts into the controller. Now another setting in the GEVCU is how long the Precharge relay is engaged for, and right now I've got that set for 3 seconds. After 3 seconds, the second control wire, which comes in here, engages the main contactor. When the main contactor closes, we have pure 60 volts flowing through the system. This Precharge circuit essentially comes out of the circuit and plays no further role. With full power flowing through, I've got these halogen bulbs simulating the load of a motor. Now right now these are 20 watts each, so we've got 100 watts worth of power consumption. The motorbike's got a 3000 watt motor, so that's very, very small, but at least it'll let me check out to see the functionality of the Precharge relay and the contactor and make sure the power and current is coming through as we would expect. So let's take a look at the firmware settings, and then we'll power it up and see what happens. Okay, we are now in the firmware, and let's take a look and see what our important settings are. Right now I've disabled all the devices that are not in play. I don't have any of these devices in the circuit. I do have a test inverter, which is required. I'm transmitting data over Bluetooth. Haven't tested that yet. And this is the Bluetooth module. But the important thing we want to look at are these 3 numbers right here, the Precharge controls. So the Precharge relay delay is set to 3000 milliseconds or 3 seconds. The Precharge relay control output pin is pin 0, and the main relay control pin is pin 1. So that is the way the GEVCU has been wired. So let's go ahead and
power it up and see what happens.
Okay, because of the way the GEVCU powers up, if it's getting power from the USB connector in the laptop and power through the traditional power setup, it actually bypasses the Precharge relay system for some strange reason. So I always have to make sure I have the USB unplugged. And what I'll do is I'll turn on the battery pack now. So that assumes that the battery is actually in the battery pack in the motorbike. Now I'm going to turn on the 12 volt power, which is the same as turning the ignition key. We're going to hear a small click from the Precharge relay. We're going to count to 3. Oh no, sorry. When the Precharge relay goes, we're going to see 60 milliamps from here. And after 3 seconds, you'll hear a big clunk with the main contactor goes, and then we're going to see around 60 volts on that display, and this will jump up to 60 divided by the resistance or the power of each of these bulbs should give us 1.7 amps of full power. Okay, so battery pack is on, and ignition key. Small click, 1, 2, 3, big click, 1.7 amps, and 60 volts, close enough to 60 volts. So the circuit is performing the way I need it to, with full Precharge relay and main contactor control functional. So that's great. Now let's figure out how we can read this voltage in software in the firmware here.
Okay, so one of the things we need to do in order to properly read the voltage is to calibrate the inputs of the analog to digital converter. And we do that using the capital A command. And it's running through the analog to digital inputs, and you can see it's reading non-zero values from the input, but it's going to take those as the true zero. Okay, so all of the values are zeroed out. Now what we need to do is come down here, and we'll see the commands we need to run. We're going to run the pack low calibration, and we're going to set that to 0. So in addition to running the A to D zeroing, we're telling it that the low value of the battery pack is really 0. And this comes through in 1/100th of a volt, so 0 is still 0. Okay. Now, what we're going to do is run the pack high calibration. And that really wants to be that value about 59.4 or something like that. But what I need to do is power up the battery. And in order to do that, I have to disconnect from the console, power up the GEVCU as if it was not connected here, and then we'll take a look at the values. So we got to come back in a second. Okay, the simulator is all powered up, and I'm reading 59.2 volts. So we run the pack H cal command at 59.2 volts, but we have to multiply that number by 100. So this is the value that gets entered into the firmware. Now, cross your fingers. Okay, so what happened is the A to D input was sampled 500 times, then that value was summed up and then divided by 500, which gives us this target number, and then using that it calculates what the gain of the analog to digital converter input is. 1-to-1 input gain is 1024, so this is just being reading as amplified just a little bit. Now, system's up and running, the battery pack is on, so let's have a look and see with the L command what we're actually reading for our battery values. And we're seeing 55.94, 55.60, 55.64. That's not great. Oh, now we're up to 59.08, 59. 57. We're getting a lot of drift up and down. My meter is staying rock steady at 59.2 volts. So we're within a volt or two, which in the big picture is probably good enough. It'll be a little bit high, it'll be a little bit low, so hopefully it'll even out. But the big picture is we're reading voltage, battery pack voltage, successfully with the GEVCU. That is job done.